Module 10 quiz for the hybrid chemistry class. One of the questions on the last quiz asked you which of these were in the final balanced equation. One of the things that you'll have to do in this one is to write the products. You cannot write products unless you can classify what the reaction is. I classify this as an acid-base reaction because I see that there's a hydrogen in front of this compound, which makes it an acid, and there's a hydroxide over here, which makes it the base. So this is an acid-base reaction, and I know that those products means it makes salt plus water. Even if I didn't know that what those products were, I do know that the cations switch positions, which means aluminum will pair up with sulfate and one hydrogen will pair up with one hydroxide. Remember, you only put them into 1-to-1 ratios over here because we need to check charges to figure out if there are any subscripts over here. So don't be focusing on that there are 3 hydroxides over here. You don't bring 3 hydroxides over here. You only bring 1. Checking the charges, I know that these are the charges of the ions on the right side, and crisscrossing them, I get these as my products. Now it comes time to balance them. One of the strategies that I would use in this particular one is the Polyatomic Rule. I have 3 sulfates over here, 3 units of it, and I only have 1 unit over here. So I'm going to balance the sulfates. Another strategy, again, stay away from hydrogen and oxygen right now, is I'm going to balance my metals. And I have 2 aluminums on this side and only 1 on this side. So here I am balancing the aluminums. I know now that I have the same number of sulfates and the same number of aluminums on each side. What might be another strategy that I could do to go on and balance this? One of the strategies would be not to choose oxygen because oxygen appears in every single compound, which automatically makes it difficult. So I'm going to check if my equation balances by checking my hydrogens. I have 2 sources of hydrogens here, which makes it a little bit more difficult, but I only have 1 source on this side. So let's count how many hydrogens I have in this aluminum hydroxide. Remember, you go front, outside, inside. So front 2 times 3 times 1 is really 6 hydrogens from this compound. Front, and I go down, is 3 times 2 is 6. So I have a total of 12 hydrogens on the left side. I only have 6 over here, so I'm going to put a 6, that's a 6, in front of the water, and I now have the same number of hydrogens. Let's check to make sure I have the same number of oxygens. I have 2 times 3 times 1 is 6 oxygens. I have 3 times 4 is 12 oxygens. So total oxygens on this side would be 18. Let's check how many oxygens I have over here. I have 3 times 4 is 12 because there was no coefficient in front. I have 6 and times 1 is 6 oxygens. So I have 18 on this side. I have a balanced equation. Again, I check one more time to see if I have to reduce the coefficients, which I do not. There is not a number that goes into every single coefficient, so it's balanced. So looking down on here, the first one looked at the beginning part of predicting a product. This is not a balanced compound. The charges have not been crossed, so that is not an answer. I notice that this one has 3 waters when I really needed 6 to balance it. This has 2 in front of the sulfuric acid. I needed 3. And this one has 6. So my answer would be aluminum sulfate. It exactly matches that. When an acid reacts with a base, which product always forms? One of the patterns you have to remember for this exam is that an acid plus a base gives you a salt plus water. Salt plus water. What is a salt? Salt is nothing more than a metal attached to a poly or a metal attached to a nonmetal. The equation that we just had previously done is an example of an acid-base reaction producing salt plus water. Carbon dioxide will only be produced in combustion reactions. Here we have water, so C is the answer. Classify the following reaction. Again, you're looking at keys to be able to do that. And I notice that I have a hydroxide in here and H there. That's my red flag that it's an acid-base reaction. So I'm going to circle that. I can cancel this one out because it's always carbon dioxide and water that's formed. That wasn't one of the products. Precipitation reaction is any reaction that produces a solid, and that is not up there. So I could cancel. The type of reaction illustrated by the equation below is, what are some of the patterns that we talked about in class for you to be able to classify? Remember that if there was one product formed, it was a synthesis. Synthesis or combination reactions are nothing more than putting a bunch of products together to make a bunch of reactants to make one product. A decomposition reaction is the opposite, where you take one reactant and tear it all apart. And so this is an example of a synthesis reaction. It is not a combustion reaction because remember, combustions are a carbon-hydrogen compound burning in oxygen, making those products. So it does not follow that pattern. It follows the pattern of a synthesis reaction. Here we are mixing these materials together, and they want to know what is the correct net ionic equation. Here I have written the reactants, and again I am switching the cations. There is one Pb that will join the S and one H that will join the NO3. I have put the charges in here already so that I can crisscross them. And when you use your solubility rules, you'll see that lead sulfide makes a solid. Next thing you should be doing is balancing the equation, because that's part of being able to determine what the net ionic equation would be. This example of what I have done is called a molecular equation. Molecular equations are going to be equations that have reactants and products written in compound form. They're not in ion form. And these are the ones that you'll be classifying if they would be a synthesis, a decomposition, or a combustion reaction. Now I'm going to break the molecular equation into its respective ions, and this is after I've balanced the molecular equation, and I split these apart, keeping the solid together. This is called the total ionic equation or complete ionic equation. I'm going to cross then out ions that appear on both sides, on opposite sides. Again, these are called spectator ions. They're just kind of hanging around looking at things happen. And then I am going to take the ones that were left over and write them as the solids. This is called a net ionic equation. Net ionic equations are those ions involved in making the solid. So here are the three equations from the previous page: the molecular, the complete or total ionic, and the net ionic. So the net ionics will always be those ions involved in making the solid. So C is the correct answer. If you take a look at what each of these are doing, this is a combination of both a molecular and a complete ionic equation. The net ionic equation for the molecular equation below is, again, it's just asking you to look at those ions involved in making the solid. Always make sure the equation is balanced before you go ahead and answer that question. But without even breaking them into ions, without even separating them and crossing all those out, I can rule out many of these because this has ions involved that are not involved in making the solid. This broke the solid apart. Should not have done that. This at least kept the solid apart, but I still have these spectator ions that were not involved in making the solid. These ions are the ones that made the aqueous product. That's not what a net ionic is asking for. This is the only one that shows the ions involved in making the solid. Which is a valid general definition of a salt? Remember, a salt is any compound that's a metal attached to a polyatomic or a metal attached to a nonmetal. And all of these are examples of salts. A, which is NaCl, is what we call salt in normal everyday life, and that's just a normal name, like we call H2O water. Actual name is dihydrogen monoxide. So we have common names is what I'm looking for. Common names. So NaCl is known as salt, but salt is a family of compounds that have metals and polys, atomics, or metals and nonmetals. So in this one, D would be the correct answer because in an acid-base reaction, it makes water and a salt. The equation below is an example of what type of reaction? Equation below is an example of what type of equation? Let's look at our choices. We have total ionic. Remember, that's an equation that shows all the ionic compounds as ions from a balanced equation. I don't see any ions written in this. A net ionic, again, is only going to be those ions involved in making the solid. There wasn't even a solid on the product side, so that's false. And a molecular equation is going to demonstrate the chemical reaction of several compounds. Again, these are the ones that you classify into whether they're synthesis, decomposition, single replacements. And this is an acid-base reaction because we have a hydroxide and a hydrogen ion. So I could classify that. That is a molecular equation. The total ionic equation, we're into total ionic. That's not a net ionic, so you're looking for that. It shows all the ions involved in this equation, and you keep the solid together. So whatever my options are below, this AgI should be held together because it's a solid. And let's see, in this one, they split that one apart. This one doesn't even show the AgI in it. This is a net ionic equation because it's the ions involved in making the solid. It's not what the question asks. As for total ionic, it's not the same as the molecular equation, so B is going to be your answer for this problem.